Hello friends, myself Rajendra Mahajan presenting my video on inverse Laplace transform. First example, find inverse Laplace of 1 upon s square plus s, and to obtain its solution we rewrite that term 1 upon s square plus s as we take s common from these two terms. Remaining terms are s plus 1, and therefore inverse Laplace of 1 upon s square plus s nothing but inverse Laplace of this new term 1 by s multiplied by s plus 1, and therefore applying the property of inverse Laplace transform, whenever any f bar of s multiplied by 1 by s, it is integration from 0 to t inverse Laplace of remaining term is here 1 upon s plus 1, and then its integration with respect to t. Therefore integration from 0 to t, inverse of 1 upon s plus 1 is e raised to minus t, standard rule or standard result, and then integrating it with respect to t, we get integration of e raised to t minus t is e raised to minus t by minus 1, limit from 0 to t, cancelling that minus sign by changing the limit, 0 become upper, t become lower, therefore e raised to 0 minus e raised to minus t, but e raised to 0 is nothing but 1 minus e raised to minus t as the inverse Laplace of that first example. This is the required answer. Second example, find inverse Laplace of s minus 6 divided by s plus 1 whole square plus 4. To find the inverse, if we see the term in the denominator, here s is replaced by s plus 1. Therefore, everywhere s must be replaced by the same term, and therefore rewriting that s minus 6 as s plus 1, we add 1, subtract 1, so that no change in the original value, and whole divided by s plus 1 whole square plus 4 means it is 2 square divided by s plus 1 whole square plus 2 square. This is the first step, rewriting that s as s plus 1 and then minus 1. No change in the value, only form we are changing, and therefore taking inverse on both sides, inverse Laplace of s minus 6 s plus 1 whole square plus 2 square is equals to inverse Laplace of s plus 1 whole divided by s plus 1 whole square plus 2 square, and minus 7 divided by s plus 1 whole square plus 2 square, and its inverse. S is replaced by s plus 1 in both numerator and denominator using shifting theorem. We get it is e raised to minus t into inverse Laplace of neglecting that plus 1, the remaining terms are s upon s square plus 2 square. In the same way, for the second term, minus 7, inverse Laplace, it is e raised to minus t, inverse Laplace of, remaining terms are 1 upon s square plus 2 square. And therefore, it is e raised to minus t, inverse of s upon s square plus a square is cos at, cos of 2t minus 7. Inverse of 1 upon s square plus a square is 1 by a is here 2. And inverse of that s square plus a square is 1 by a sine of at, sine of 2t is the required answer into e raised to minus t. Therefore, the final answer, we can take e raised to minus t as a common. Remaining terms are cos 2t minus 7 by 2 sine of 2t as a required answer. Third example, find inverse Laplace of 5s square 3s minus 16 whole divided by s minus 1, s minus 2 and s plus 3. We see the term from numerator, its degree is 2, and there are 3 factors in the denominator, s minus 1, s minus 2 and s plus 3. Its degree is 3. 2 is less than 3 means it is a proper fraction. Degree of numerator is less than degree of denominator. And as it is proper fraction, using partial fraction technique, all factors are real and different. Case 1, and as per that case, we can rewrite that term 5s square plus 3s minus 16 whole divided by s minus 1, s minus 2, s plus 3 as a upon first factor, b upon second factor and c upon third factor. And we call this equation 1. By shortcut method, we find the value of e. Here the LCM is the product of that 3 factor, s minus 1, s minus 2 and s plus 3. Dividing by s minus 1 to that product, remaining terms are s minus 2 into s plus 3. Therefore, we get a is equal to 5s square plus 3s minus 16 whole divided by, neglecting that s minus 1, remaining terms are s minus 2 and s plus 3 at s is equals to 1. Equating this s minus 1 to 0, we get s is equals to 1. And then substituting this value, we get 5. 1 square is 1. 3 into 1, we get 3 minus 16 divided by 1 minus 2, we get minus 1. And 1 plus 3, we get 4. And therefore, it is 8 minus 16 divided by minus 4. Minus 8 by minus 4, we get that value as 2. The value of a is 2. Then we find the value of b. This time we divide by s minus 2 to this product. We get b as 5s square plus 3s minus 16 divided by remaining terms are s minus 1 and s plus 3 at s is equals to 2. And therefore substituting value as s is equals to 2, we get 5. 2 square is 4. 3 to the 6 minus 16 divided by 2 minus 1 we get 1 and 2 plus 3 we get 5. 5 for the 20 and 6 minus 16 we get minus 10 and divided by 5. 10 by 5 we have the value of b as also 2. Then we find the value of c as this time we divide by s plus 3. We get the value of c as 5s square plus 3s minus 16 divided by remaining terms are s minus 1, s minus 2 at s is equals to minus 3. Therefore we get 5 minus 3 square is 9. 3 into minus 3 we get minus 9 minus 16 whole divided by minus 3 minus 1 we get minus 4 and minus 3 minus 2 we get minus 5. 9 5 is the 45 minus 9 minus 9 minus 16 we get minus 25 and 5 for the 20 minus 20 and therefore we get 45 minus 25 that is 20 and divided by minus 20 we get the value as minus. Substituting these values in equation 1 we get therefore that 5s square plus 3s minus 16 divided by s minus 1, s minus 2 and s plus 3 is equals to a upon s minus 1. The value of a is 2 divided by s minus 1. B is again 2 divided by s minus 2 and c is minus 1 divided by s plus 3. Inverse Laplace of left hand side 5s square plus 3s minus 16 whole divided by s minus 1, s minus 2 and s plus 3 is equal to inverse of right hand side. Constant term we take outside, therefore 2 into inverse Laplace of 1 upon s minus 1. Again 2 constant outside, inverse Laplace of 1 upon s minus 2 and minus constant term inverse Laplace of 1 upon s plus 3. Inverse of left hand side is some f of t. 2 into inverse of 1 upon s minus 1 as per standard result it is e raised to t 2 times inverse of s minus 2 is e raised to 2t, a is here 2 and minus for s plus 3 its inverse is e raised to minus 80 minus 3t as the required answer. Therefore, in this small video, I have explained 3 examples of inverse Laplace transform. Please like my video, share it, as well as subscribe to my channel. If you are not subscribed yet, please subscribe to my channel and to receive the notification for my all such type of new videos, please press the bell icon. Thank you. Thanks for watching.